Yep, I'm doing this again. Aha! I just want to show you guys these games, right? Like, there's a bunch of them. I just got this one, so I'm going to show you this, but they're all pretty similar. Yeah. And they have different aesthetics. Like, this one has kind of a Soviet chemistry computer thing going on, but they all have their own little sort of deals. There's one that's about alchemy. There's one that's about futuristic chemistry. And there's some chemistry themes, but mostly they're just little puzzle games. And I listen to dub music when I'm playing these games, but if that doesn't choke your boat, then choke your boat. Oh my goodness. So yeah, let's just go to a solution I've got here. Basically, it wants this, and you've got some toys to play with, and when you have a solution that works, it probably looks something like this, depending on how complex it is. But generally, you're trying to build a machine that builds chemical compounds, at least in Molek Syntez. Da. So let's start a new one. I've been playing for a couple hours. I played these games before, so I know a little bit about what I'm doing, but the rules for each little game are different, right? And in this one, you've got to build chemical compounds out of pre-existing chemical compounds. So like in this example, we've got to build all this. And that looks pretty complex, but we've got some building blocks. And it looks like the basic building block is going to be benzene in this test. Let's just kind of lay them out. So it's going to be something like this, but with some kind of sulfur in the middle, and again, nitrogen, pretty easy. We can just use this ammonia and make some small tweaks, and that should work. The trick is going to be the part in the middle, but as I look at this, it looks like the portion here and this portion here are the same, right? They're just flipped. As far as I can see. Okay, so chemistry basics, as far as this game is concerned, not sure how accurate it is for actual chemistry, but each atom can have a certain number of molecular bonds, and here's the maximum number of bonds that they can have. So for example, this carbon here can have 4 bonds. It's got 1, 2, 3, and then this bond with this little hydrogen atom makes 4. So if we were to remove this hydrogen atom, we'd free it up for a bond. So let's just do that. We're going to use this little guy. He's kind of our actor, right? In a visual programming sense, he's our agent that's available to do something. So if he did that, he removes it. Now, it can't form a bond with this nitrogen because it's got the maximum number of bonds that it can have. So we would strip that too, right? And then boom, we're set up there on this end, right? And so let's just get completely set up on this guy. Boom. So at that, just like that, we're ready to bond with whatever we're gonna stick to, right? And we're ready to ship this whole deal. The problem is that we've only got 6 of these little actors, right? And we've still got the sulfur and oxygen sort of middle component problem to solve. And that's going to be a little bit trickier, I think. So let's get rid of these, and let's make a workspace here to look at that. So the only molecule that we have that has sulfur in it is this sulfuric acid, it looks like. And it looks like, we've got some work to do here. So we've got to get rid of these 2 oxygens, and then we've got to get these hydrogens stripped off of these 2 oxygens in order to get ready here for the big show. So I think what I'm going to do, this is going to take the most amount of work. So I think what we're going to do is we're just going to get that happening here. So we're just going to use 1 and 4 here, and we're going to strip those. That's good. And then we're going to actually add some hydrogen to these other 2 oxygens. And what that will do is make it so that they can't actually have any other bonds, right? And then what we're going to do from there is we're going to go ahead and delete. Boom, boom, boom. And we're ready. So that's 3 whole steps. And we're using all but 2 of our little computer agents here. Our little, basically, hydrogen farters. I don't know what they're called. So, let's see what we can do about the rest of this, right? So we've got this benzene. And we can actually start with it there, right? That's not hurting anything. The problem with that is we can't actually get to this little hydrogen here. Because we're going to need to remove that in order to get it to stick to this sulfur. So, we need to get it where we can actually get to it. And this is where all the tricksiness of this game comes in, is how do you orient these things so that you can get to them, so that they're useful. And that's where the kind of the puzzle of the game comes into. Once you understand the rules, then you can really start playing with it. And if your brain is fried, it's not going to get any better. It's going to get worse. So just, you don't have to watch. Leave me alone. Leave me to this. But I'm just going to ramble and play this game until I solve this puzzle. And I don't know how long that's going to take, but I'm going to do that. If this seems interesting, then you should probably, you should buy this. It's like $3. Or you should actually, what you should do is you should go look at the Zachtronics page and see if you like the idea of this, or if you like the idea of machine language programming. There's Exapunks. Infinite Factory is like probably the most accessible one of these games. It's like 3D, it's a first-person game where you actually walk around, but it's simpler. It's the same game, it's just more accessible. So I would start there. If you're intrigued, but this is too much, that's where you start. But fuck it, I didn't want to play that. I just got this. I want to play this. So I'm going to play this. So I need to get to this. So at this point, I need to see if I can basically, instead of using 4 to do the function here, I can just as easily use this 5, right? So what we're going to do is we're going to transfer this instruction here, and that frees up 4. We're going to come up here and use it to remove that, right? Blah. Perfect. So now it's ready. And the same could be said, we're not really using 2. Interesting. Because we're going to need nitrogen here. So we can go ahead and use 2 for that. But then we're just so far out. I think this is the first time where we're actually going to... Basically, we're going to have to build a machine that can build half of this and then have it do it again. That might be the most efficient. It's symmetrical in a lot of ways. And I think we can play on that symmetry to get a machine that can do this rather quickly. So let's think about this. If we just need to prepare one side of it, we ignore the bottom part, we ignore this little hangers-on, and we're going to try and do that as quickly as possible using, say... Let's try it using just 3, right? Just 3 machines. Because if we can do it using, like, say, 2, 3, and 4 here, then we can do the exact opposite using 1, 6, and 5 here. So let's try that. So remove that. 3 is going to have to get in there and remove that. And 4 can go ahead and remove that. So that at least will set this up, right? So that's ready. And then we just need to get rid of this guy and make some changes here. So after 4 does that, we're going to have it boot scoot that way. That's correct, right? Nope, wrong way. Boot scoot this way. And then add a couple of molecules and then delete. Now, I'm not doing it fast, I'm just doing it, right? As quickly as possible. Not really, but we're trying here. And then we're actually going to go ahead and remove that hydrogen, right? And while that's happening, that's going to take forever, but we can figure out how to consolidate and save time there. So really, theoretically, that's already formed a bond after the first one, so we're just going to push it. Boop. Right? So that, by itself, has gotten at least the top half done, right? Now that has it. So we're just comparing this again to this, and it looks okay. Yeah, so that's gotten roughly half of it done. So we could do the same for the other side using the other agents here, but that seems a little bit slow, right? There's a lot happening. 4 is just working its butt off, while the rest of this does nothing. So what can we do to speed this up? We could have 3 do both of what it, like the things it needs to do. It could do both of these, right? So we could start 3 here, and then have it move and do it again. And that would free up 2. Meh, meh. So it still needs to push. But we could figure that out. That's no big deal. We'll figure that out here in a second. The problem is that it's just so... we can't get 2 anywhere useful. So... we might use rotation. That could be a solution. That would be interesting, I think. I feel like, honestly, though, the solution is going to be a little bit different. But I'll tell you what. This works, right? That's the thing. Like, that worked. So what we're going to do, actually, is we're just going to lazily have that happen and see if that works. Well, that doesn't work, obviously, but let's go to the end of this. Now, that looks like what we need. So what we're going to do is we're going to copy this, and we're just going to get a solution. And we're basically going to copy what we've done up here. So for 2, all 2 needs to do is push, right? So we're going to put the same instruction here on 5. And 3, for 3 we're going to use 6 as its analog, right? And we're just going to copy that. We're going to remove that. We're going to scoot. We're going to remove that. Does that work? Yep, exactly what we want. And 1 is going to be our 4 analog workhorse. Have it start there. And we're just going to copy 4's instructions, right? Boom, 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 boom. Boom, boom. Boop, boop, boop. Boop, boop. And that looks correct to me, right? So what we can do now is we can ship this. So on this last frame, we're going to have 3. Yeah, that's terrible. We'll get there in a sec. I think at the end of this, we're going to have someone who's just an innocent bystander who's pointing in the right direction vaguely, who's not doing anything. So we're going to have, yeah, 3 or 6. We'll have 3 do it. Have 3 ship this. And then, what we're going to need to do, unfortunately, is get everyone back where they belong, which takes forever. And this is a terrible solution. This is like a donkey solution. And it still doesn't work. Why don't you work? So what's wrong with my product? You don't like my product? This all looks right. Let's see, 3's trying to grab it. And it looks okay. What's wrong with it? This looks fine. What's wrong with this product? Let's take it step by step. Now you're trying to grab it right there. Everything's hooked up. What's the deal? Oh, this bond is incorrect. What's wrong? This whole bottom section is incorrect. No problem, no problem. We just need to rotate this and put it there. And that should solve our problems here. Boom. And then it will reset. So that should... That's a depth zone factory is what we built. So what this game does, you'll see these gray squares. That's where these molecules are. And if there's room for a new one to pop in, it will. And so that's one of the other little rules of this game. That works. And that is slow as hell. Totally inefficient. But it is a solution. And that's one of the things about this game. That's Daniel. Daniel May. And usually he's really competitive. Usually I have to really scratch my head to get to where he's at. So I don't know if he just dropped the ball in this game, or if he's misunderstanding one of the core concepts or something. Usually he is right there, and I have to like fight to get equivalent to or along with him. So Daniel, you know, step it up, buddy. What are you doing? What's this? Huh? What's that? And you can see, like, you can really focus in and say, like, I want to focus on having the fastest one, right? Or the one that uses the least number of instructions, or the least number of modules. And that's pretty cool, but I could go back and, like, tweak this, right? And there's definitely a faster solution to do this, and I'm going to do that. And if you guys are interested in that, let me know. But this works. So the real puzzle with this game, you know, this is a puzzle, right? And it's something. But I think the real puzzle is trying to optimize your solutions. So, like, let's just go look. This is a simple one here, I think. Ooh, unlock some more. Here we go. So, like, here's an example, right? I had this. And this was before I realized that I could rotate these atoms. Or these molecules. And so I was, like, before I placed them, I mean. So I was, like, rotating them by hand, and it was really goofy. But once I realized I could do that, the solution... much quicker. So yeah. You get to the point where you can make better solutions. Looking for a better example here. Like, here's my first solution. Look how awful that is, huh? What am I even doing? I think I didn't realize that I could start with a better molecule. But you get to the point where you can, you know, optimize it. And I don't know. It's fun. You know, it's pretty good. Check it out.